What is up today in the world of pwn.college? We'll wait until we are live on Twitch. Having a little snack. There we go. We are live. All right, first question already pouring in. Am I feeling any better? I am not feeling better. I'm not feeling terrible, but I have a very persistent, very annoying cough. Still doesn't look like it's COVID from the tests, but it's. I thought I was gonna die yesterday coughing, but I made it through. So at least made it through last night. Hopefully things will get better. I'm mainlining cough syrup at this point. It's pretty crazy. Anyways, but I always have enough time to talk about embryo SM and baby shell. Probably baby shell, since that's the critical one. Let's give people another couple minutes to filter in. We'll keep enjoying this snack, and then we'll dive through, the state of the class, the meme review, and then we'll go on from there. How's everyone finding baby shell so far? Fun is good. Painful is also good. Painful is type 2 fun. Might be fun. Potential type 2 fun. Might be fun in retrospect. Has been referenced as baby's hell. That's awesome. Yeah, baby shell is going to be the easy. Well, it's probably the second easiest module of the year, other than the embryo SM and so on. It's going to be yeah, exactly. So other than like embryo SM, embryo IO, and baby suid, baby shell is the next easiest one. We're going to get even more exciting from here. We have a hacker from last year joining us on Twitch. Welcome. That's awesome. Now, I didn't say it was the easiest module. Someone on Twitch is despairing because I said it's the second easiest module. So think about this, like if I don't know, if you were solving the world's toughest problems and there was like the second easiest of the toughest problems, it's kind of like coming in second to last in the Olympics, right? You're still, an Olympian. So you're still an awesome hacker. And you will get through it. You can get through it. Pooja, the easiest one is for sure baby suid. Baby suid is by far the easiest module. It used to be our weed-out module, but and to make it our weed-out module, we had you come up with 100 different binaries to abuse. It was tedious more than educational. So then we changed it into what it is right now. But then to kind of make a additionally filled out early education for this course, we made Embryo.io as well. All right, let's roll. We're at 4:35. Everyone should be here. We have 86 people. All right. Let's make it happen. We have a question. When is the class going in person? The class is going in person when I get better. We'll still stream. It'll just also be in person, so you can choose which modality you want to take advantage of. But I honestly didn't think I'd be sick for 3 weeks, but here we are because this is week 4. So I think this is week 4. Let's start out with Ctf Extra Credit. Last weekend we had 11 students on 3 teams tackle 1 Ctf, Al's Ctf, and there was a total of 3 flags retrieved. The team that got the 2 non-sanity check flags managed to not get the sanity check, which is pretty awesome. I've been in my share of absolute insane situations where there was a challenge that should have been for sure solvable by, CTF experts of our caliber, but it turned out we were total noobs and we were unable to solve it. My favorite example is from, I think it was Dragon Ctf Teaser, where Mike Pizza and I spent, I think Dragon Ctf Teaser had like a kind of a reduced amount of challenges. A typical Ctf is like 20, 25. This had like 13. Many of them were pwnables, and very quickly Shellfish burned through all the pwnables, right? So we were done with the pwnables. What was left was like Web 100. 100, well, I think it was 150 in our defense. A 150-point web challenge that was like, baby's first cross-site scripting or something. And Mike Pizza and I spent 24 consecutive hours on that challenge, and we almost solved it. It was very, very close. So, shit happens. Sometimes you don't get the sanity check challenge. So, yeah. Someone on Twitch said they probably didn't solve it because their team didn't have sanity, which is very possible. All right. Next weekend, what's coming up? Well, the big news is Seesaw Ctf Qualifiers. If you are an ASU student, I'd highly recommend playing this one with the ASU Hacking Club. They typically play as Shellfish on the CTF scene. Contact them through their Discord, especially if you have a couple of solves under your belt from the rest of the class. Seesaw is a big, important one. I showed it off the website last time, but we can just Google it for it again. Seesaw21 Ctf. One of the oldest and biggest CTFs. I used to say Shellfish is the oldest and coolest hacking team. So once you're starting to brag about being old, things are going, somewhere. But Seesaw is important. It's an entry-level event, but it's definitely not easy. It's gonna challenge you. It's gonna be really fun. And I highly recommend it. I've had a blast every Seesaw I played. I've never played Seesaw as an undergraduate, so I was never eligible for going to the finals. The Seesaw finals are always a blast. I'm not sure if it's in person or not this year, but either way, it's both rounds will be online. But either way, it's a great way to kind of get into the brain space of people who matter in recruiting and so forth. So good career opportunity too. All right, awesome. So there's a Let's roll on. There's a question about joining the ASU Hacking Club as a non-ASU student. I don't think that's possible. Maybe they have a public channel. I know the Shelfer CTF or the Shelfer Discord has a public channel for what it's worth, just for chatting. All right. Also pwn.college is a public Discord. All right. There's a comment there. No CTF thus far has felt entry level. That's very, very true. But this is probably the most entry level CTF, or at least the one that will strive to be entry level more than others in this semester. All right, let's talk about some memes. I'm going to be moving my. Well, this is a meme I made. Here, I'll fly my camera. There we go. All right. The helpfulness ranking, PyPy62 has definitely taken the high ground. So we'll see if Ethan G45 can keep up. Those are the two highest ones, and then there's like a whole other part of that leaderboard. I'll put it up here with more original memes from yours truly. All right. The schedule. The big thing, of course, is that we are extending shellcoding by 2 days to Thursday. So today is still a shellcoding day. We'll launch sandboxing on Thursday. Why are we extending shellcoding? Well, we're extending shellcoding because of this. Because though Embryo ASM pulled people up quite high, which is what we were hoping for, give people a nice refresher to assembly, they raced right back down, unfortunately, afterwards, which is a bummer. But I think it also had something to do with the long weekend, and probably people had other plans than to spend it shellcoding. What does this do to our schedule? It's a little tricky. So I had three classes of exploitation here, followed by the fall break for more exploitation, and where we'd hold an exploitation office hours. I squished it to 3. This is extremely optimistic. If we can catch up the time, maybe we can do reverse engineering quicker. That'll be good. If not, the likely scenario is we'll eliminate this architectural vulnerabilities module and ship the rest of the class. This would have been a new module around Spectre, Meltdown, and these sort of things. Maybe we're just trying to do too many things in one semester, and maybe this would be better served for spring's advanced x86 class. But yeah, let's see what happens. For now, we're gonna launch sandboxing Thursday, and we'll go from there. All right. The current grade distribution per homework. So Embryo ASM is proving to be a little harder, much harder than Baby Suid. People are squeaking out A's in it more than A pluses, but also lower grades as well. Baby Shell is currently proving to be very, very difficult. I have some analyses that I run to try to estimate how many students are still trying in the class. Right now, we still have 105 registered. And out of those, based on Baby Shell attempts, I think we still have about 78 or so that are trying in the class, but we'll see. If you haven't started Baby Shell, this extension isn't going to do much for you, but it'll at least help you scrape back some amount of score. We're, of course, in a bad position in terms of there's a question on Twitch. Are these numbers everybody or just the ASU students? These are just ASU students. All of this module score graph, everything is just ASU students. That lets me bind, people and analyze based on data that thing has real world backing. All right, The problem for the curve is that this is kind of spreading out the, spreading things out in a bit of a weird way. I've decided to keep things uncurved for now. So no curve yet. At this point, almost half the class is failing. But of course, that's if we had stopped Baby Shell today. Hopefully by Thursday, we'll be in a bit better situation. A plus is 99. The A category is not including A plus. A plus, except, yeah, anywhere. A plus starts at 99% for us. All right. So, TLDR, the due dates. Baby Shell is getting extended. The rest of the, actually, A is 90 to 99. The rest of the modules are now half credit, or in the case of Embryo.io, 75% credit. And that is where we are. All right. Let's do some meme review. We had a lot of memes because I forgot to do meme review on Thursday. So we got some general pwn.college memes coming up first. I've never seen a meme review. I just kind of heard the concept and stole it. Am I supposed to give credit for these memes? I should probably give credit. Anyways, feel free to give yourself credit on Twitch live. But we had a good meme. I see extra credit. Yeah, that's good. I had someone had a good meme. They were first on pwn.college for 10 minutes. But hey, you were first on pwn.college. That is awesome. Actually, let's take a quick look at the scoreboard. Who is first on pwn.college? This week's top flyers, Pie62, great job. Followed by Naughty Boy, Owl, Bob, and Trees. Great job, everybody. This is it's awesome seeing everyone battle for the top spot. This is very cool. The current requirement, wow. So full solves will get you to 34th. No, 35th. Very cool. Jordy, get that last flag, and you can secure this spot. All right, very cool. What do we got? We got this was great. Of course, chmod is a useful way to solve a lot of these challenges, especially when you don't have easy exfiltration, etc., etc. Someone took away all of their permissions to their home directory. This is not so good, and of course it breaks the web interface, but you can still SSH in and fix your stuff. That's a funny thing. Finally, next up we have this meme, which is a source of frustration for me. Of course, this class is a what you might call a hybrid class. The lectures are pre-recorded on YouTube. Nice, theoretically easy to consume, videos, etc., etc. And then you're supposed to watch all of them, then come to class, and then do the challenges. But no one does that. Everyone starts trying to hit the challenges, knowing nothing about the topic. I think it's a problem that I think will solve itself as we get more and more into complex computer system security concepts. But right now, this is where we are. People tackle the challenges, and then when they get stuck, they go and read the slides, and if they don't understand that, then they look up the lectures. Not how it's supposed to go. This isn't how school is designed. But maybe I don't know, maybe it's how school should be designed. All right, this one is good. Some some people were brute forcing flags even back with wget when it would lowercase your flag on one of the ways to retrieve the flag using wget. I'm gonna add here, this is a big no-no. Do not take flags from each other. That immediately triggers academic integrity alerts, and it's just a big pain in the ass. Really, get your flag and submit it yourself. This is the way. I'm very touched that, you know, someone at least made a meme saying that pwn.college is their favorite Discord. That's pretty awesome. All right. Yeah. Ramen, you should have said hacking the website to increase your point counter. That's good stuff. Ah, man, if you brute force a flag and it happens to be someone else's flag, that's interesting. Hopefully that would be a Connor fail. I think Connor theoretically made all of these cryptographically spread out enough, hopefully. All right. Anyways, and then of course there's the embryo assembly phenomenons of no flag for you. Which, on that topic, is there a collision chance for flags? I don't think so. I don't think flags can collide. I think they're a permutation. All right. On that note, there's a lot of good memes about shellcoding and assembly. This is a great one. I don't know why we teach people MIPS. This is I'll record like some sort of a Zardes rants one of these days about like why MIPS in computer organization. I mean, why hamstring people? Like, you know, there's some argument to be made. Yeah, MIPS is a simple architecture. Not true, by the way. MIPS is a giant pain in the ass. You have to start talking about branch delay slots and all this bullshit that real architectures in the real world, and we're talking x86 and ARM and you know, I mean, maybe as the, I don't know, it's just not branch delay slots and all this MIPS bullshit isn't something that should come in to these vulnerable young minds and just poison people against assembly. Anyways, but computer organization is taught here in MIPS and almost everywhere in MIPS. You know, it's so like that Simpsons meme, you know, it must be everyone else that's wrong. I think so. All right. We're doing our part to kill MIPS. But that doesn't mean it's easy. I like this one. This one's good. Level 14, of course, requires you to write an extremely short shellcode. This is a very meta. It's good. I like it. And then don't forget symlinks. Symlinks are also important. If you missed office hours yesterday, I know yesterday was a holiday, but go back and review the VOD from yesterday's office hours. We'll sync it to YouTube as soon as we have a chance. And go back and review those office hours. We covered the use of symlinks to shrink shellcode. We covered levels 1, 3, and to an extent 4 of Baby Shell. Important stuff. Then, of course, eventually, this meme here I'll leave as a hint. Whoever made it did a great job. You can have /flag as your path. You can have a symlink called lowercase a. You can have a symlink called capital Z. For various reasons, that is more useful than lowercase a. For example, because it might have other meanings already in assembly. Then you can have a symlink called it some insanity. Why? I'll let you think about that. All right. Then this monster meme. Hopefully this works. I ran a quick test, but let's see if it flies. I'm gonna listen to it through this headphone so that you don't get noise feedback. This is a crazy meme. Very, very high effort. Let's listen. One day, maybe we will mess up. Amazing stuff. That was pretty incredible. I don't even know how you would make a meme like that. Insane. Charles. We really should. I'll think about extra credit for memes. It's a little bit non-academic, let's put it that way. All right. Anyways, so let's make Baby Shell happen. As a reminder, if you don't have levels 1 and 3 of Baby Shell done, I did them yesterday live on stream. A stream that's recorded, VOD that I posted in pwn.college Discord. So there's no excuse for anyone in this class not to get points for at least levels 1 and 3, and I think level 2 is trivial as well. And for level 4, I went almost the whole way. So you should be able to get that as well. There's a question for sandboxing. Yes, so let's cover that. Are the old recordings of sandboxing valid? Yeah, so the old recording of sandboxing is actually, not to toot my own horn, but is actually quite good. So let's go with those, because if I try to make recordings right now, it's going to be me like in my raspy coffee voice hacking my lungs out. It's just not going to be good. Let's... Oh man, I didn't push it. One sec. Hold on. What the fuck? Hold on. Oh. There we go. Okay. So I am pushing, and now I'm refreshing this. Hopefully it'll come up soon. Come on. Sometimes GitHub takes way too long to update. We'll just sit here until it does. Actually, that's silly. We'll come back. Anyways, we'll just go. Well, this link is also valid. I just moved the link. Basically, 4 lectures. Please watch the lectures before Thursday. 4 sets of slides. The key thing for the challenges is this lecture. If you really, well, actually, both of these. Actually, these 3. And you might as well watch this one. It's like 5 minutes long. All right, watch those 4 lectures. Practice module problems will launch 9/9 on the dojo. It's going to be awesome. All right. The module, is the new module open yet? The challenges aren't open yet. Hold on, I have to blow my nose. All right, I'm back. So, yeah, the lectures will stay the same. Those lectures are pretty good. Sandboxing hasn't evolved in the last year, and in fact, this module will really cover escaping from chroot based sandboxes and misconfigured seccomp sandboxes. Seccomp, just to kind of jump ahead to what really this module talks about. Seccomp is secure. It's like one of the technologies that like Docker is based on and so on. Seccomp is good stuff. In order to escape from a seccomp sandbox, you typically need a kernel vulnerability, which we will do later in this class in the kernel security module. It'll be fun. All right. Anyways, Sorry about that. Didn't have time to mute. Time to mute there. That was good. That was a bad one. All right. Then let's talk about Baby Shell. Any questions about shell coding? While you think of them, I will put up the 3 shell codes that we worked on last class. So we had my simple open read write shell code that just opens the flag file, reads the flag out of the flag file, writes the flag to standard out, and exits cleanly so that we know it worked. We have my no null shell code, where we went very far out of our way to not have null bytes. The final part of that was creating, let me rewind this to a less, there we go. The final part of that there was creating the /flag string dynamically so that we could write its null byte ourselves instead of having its null byte in the ASCII like we have here, right? Because 3 doesn't allow any nulls. And then we talked about how to avoid H's. Of course, H's occur when we use 64-bit width registers, but we can do almost everything except for this. I left as an exercise to the reader using the 32-bit width registers. But when we try to move the address of the stack pointer, which is where we want to read our flag, to the second argument of read, as a reminder, read takes a pointer to an address where the data should be written. When we do that, when we do this with move RSI RSP, it's 32-bit, it will encode with an H byte to signify for that instruction a 64-bit width for the registers. If we do this, it'll cut off part of the address because the address is 64 bits. Cool. All right, let's see what people are talking about. Some knowledge in Baby Shell. Baby Shell level 5. Maybe you should tackle level 5. Let's see. If we don't have other suggestions, we'll tackle level 5. How come you have to push to the stack for open? I assume you're talking about this. This my no H. Oh, this is a leftover from my no null shellcode. That's silly. Oh, no, it's not. I was pushing the flag value to the stack because the way that we were doing that before, we had it in our shellcode and we used RIP relative addressing to reference the flag file, right? So this basically says take the value of RIP, add the offset to flag, put that into RDI. This has an H byte, hex 48 prefix. You can see it right there. .48 right here. Bad news. Okay. 5 is no syscalls. All right, yes, let's talk about 5. That's a great kind of remaining concept. Self-modifying shellcode. All right, let me spin up level 5. Sorry. What? Oh, no challenge session. Let me spin up level 5. Spin it up in practice mode. All right, here we go. As a reminder, I have my normal flag shellcode, so let's just give that a try. My open read write. This guy. This, of course, has 4 syscalls, but that's fine. Maybe it won't notice. All right, we run baby shell level 5, and it tells us we failed the filter at byte 21. So what does the filter do? This filter works by scanning through the shellcode for the following byte sequences: 0f05, which is the syscall instruction; 0f34, the sysenter instruction; 80cd, which is int hex 80, how you make system calls in 32-bit x86. And then it gives you the hint. One way to evade this is to have your shellcode modify itself to insert the instruction at runtime. All right. So what do we have? We have these byte 21 fails our filter. If you look at flag.bin, of course, byte 21, that's in decimal, I guess. In hexadecimal, that'll be 15. So here's byte 10, 11, 12, 13, 14, 15. And there's 0f05. Cool. Okay, cool. Sorry, I was catching up on Twitch real quick. All right. So now here we are. We have all of these unfortunate 0f05s. But if you look at how this code works, if we strace it, it says, okay, it gives us all these writes. Before that, it memory mapped our shellcode, a page for our shellcode that it then tells us as mapping shellcode memory at blah, 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 right? That's where our shellcode is going to be. And when it maps this memory region, it maps it as readable, writable, and executable. Now, I'm pretty sure that in the slides, I went over self-modifying shellcode, but we're going to go through it right now. And it's very simple, right? The basic idea is we're going to put a bunch of bytes here. What's a byte 13 and then byte 37. Okay, we have, instead of our syscalls, we have bytes 1337. Okay, now we have no more 0f05s here at all. Awesome. So let's actually, let's not modify this guy. Let's create a new one. All right, we have no more 1337. We can assemble this guy. As I mentioned yesterday, you should be doing what I'm doing right now in either Pwn tools or in a script you wrote, so that you don't end up with a mistake when you're trying to update all these files, because that will waste hours of your life. But I don't make mistakes. No, I'm just kidding. I do them all the time, and then it's terrifying and horrible. But all right, let's see. 0f. Yep, no 0f's in the content. Perfect. So here is our instead of syscall, we have this 1337, which is a very annoying thing because it's not a syscall. This code does nothing. In fact, I mean, it'll do stuff, but it'll crash here No, because that's a valid address. It'll crash here because it'll dereference RDI, which is going to be 2, because RDI had RAX moved into it, which had 2 moved into it. But it's the first step, right? And I'm going to show you that if we SCP this over, and we cat it, this looks like shit, and of course it's segfaulted. All right, so sorry, I didn't get to the mute button in time. So what can we do? Well, luckily we have the permission to write to our shellcode. We can see that again here in this strace, how memory map was used. Read, write, and execute. Awesome. So we can just write to our own shellcode in the same way that we read from our shellcode. We make a label. Okay. And we fix it up. So here, let's say fix up our syscalls. We'll say, okay, move. And we want a word pointer, 2 bytes. Rip plus syscall1. And what do we want? 0f05. But of course it's little endian. 050f. This will cause 050f to overwrite these 2 bytes, which will then turn it into a syscall. Let's compile it. All right, compiled it. Here's the modification. Now our shellcode is self-modifying. But this, of course, is still 1337. And you'll notice that now, again, we have 0f05 in our shellcode. That's not cool, because that's going to make us fail our constraints again. All right, so let me just show this to you. SCP it over, try to run it. It says failed filter at byte 7, which is right 1, 2, 3, 4, 5, 6, 7. Well, 0, 1, 2, 3, 4, 5, 6, 7. 0f05. All right. How can we avoid that? Well, we just write it a byte at a time instead of. So if we do this, we write 0f. Now, since we're addressing bytes, this is not, I mean, I guess technically still a little endian, but it is normally ordered. Now, we write it 1 byte at a time, and here 0f05 doesn't appear together. Can copy it in. Let's actually see what happens when we strace it. Hey, it opens our flag file. Where did this come from? This came from, let's debug it in GDB. Okay. This is going to let's print out 2 bytes at rip plus x1c minus 2 GDB. I think is a little weird. Yeah. No. Plus 2. Okay, this is where this is going to write. GDB is helpfully telling us. Here are the 2 bytes there. So why was this rip plus hex 1c? Should have been correct. F0. That was 7. Ah, okay. GDB thinks that rip right now. This makes sense. We haven't executed this instruction yet. Right now, rip is pointing here. RIP will be pointing there. So if we do look at the 2 bytes here, plus OX1C, there they are, 1337. Those are right here. And if we step over this instruction and we look at these bytes again, OF37, and now we're about to execute this guy. Now it's OF05, otherwise known, if we disassemble it, as syscall. Cool. So and then we, of course, step, and now we're stepping into syscall. Awesome. Okay. So now we opened the flag. I'm not actually going to go through the rest of the solution for you, but basically you can do the same thing for the other syscalls, right? Syscall 1, syscall 2, syscall 3. You can imagine that you can do this exact thing with syscall 2 and syscall 3. Self-modifying shellcode to evade limitations on input. Now, these limitations on input typically aren't like, hey, you can't have syscalls in your byte stream, but those do exist. There are actual analysis tools that would analyze network traffic looking for int 80, those bytes, the bytes that disassemble to int 80. What was the name of it? Was it Shelzer? This comes to mind, written by a friend of mine. But I think Shelzer was more complicated. But maybe something that Shelzer cites actually did this. So, you know, that was close to the state of the art of shellcode detection in network traffic as of like 10 years ago, right? And then, of course, throughout the class, we'll slowly catch up to modern day. Cool. All right, let me blow my nose. I'll be right back. All right, so that is all you need for level 5. We are literally with this, we are literally 1, 2, 3, 4, 5, 6 instructions away. 2 instructions each to fix up that shellcode. Cool. All right. Let's see what else. Someone's saying open read write is overrated. Yeah, it's probably much easier to have shorter shellcode that accomplishes something similar, right? In Baby Suid, you learned many different ways to read the flag. One of them was with chmod. If you look at what chmod actually does, it'll call, well, I guess it's more careful than that. There we go. Well, it'll call fchmod add. It'll call something really complicated, but there is a system call called chmod. You can use that. You can use open and send file, which I think I use in the slides often. But send file has some intricacies where sometimes it won't work depending on the settings of your terminal. Cool, let me catch up. People are talking about speculative execution for some reason. But I can't see where it started. Oh, I see. There's a comment that when you're modifying the code you're executing, oh, did I desync? Nope, it's good. Okay. When you're modifying code you're executing, you can get in trouble with the instruction cache. This is a major issue on, for example, MIPS and on ARM, depending on what exactly is going on, where you're modifying, what the processor is doing, and so forth. On x86, it's not that big an issue. In normal code, in normal times, you can basically modify your shellcode as you see, or your execution as you see fit as you execute. Now, there are cases that break that, but I don't think any that we'll cover in this class. So I wouldn't worry about it. Cool. But it is something to think about. It's called cache inconsistency when modifying your own code on other architectures. Awesome. All right. Any other questions? We just did Baby Shell level 5 to the extent that I'm very confident that everyone can finish it. You had the flag file open, as you saw. Yeah. Other questions? Otherwise, we can just move on to level 6 and take a look at that. Silence. All right, let's take a look at level 6. Level 6 is a further exploration on the theme of level 5. In level 6, okay, what's going on? Okay, let's just see what's going on if we cat our other shellcode into the challenge. All right, it's the same thing, but it removes write permissions from the first 4,096 bytes. That's hex 1000. That is one memory page of shellcode, right? And then it filters out for 0f, 05, 0f, 34, and 8 OCD. And so now we are we have no syscalls in our shellcode, but we my mind just went blank. But of course, this is solvable because all the levels are solvable. How is this solvable? Well, this is OX 1000. But you can actually read more bytes, first of all, from standard input. But even if you couldn't, if you S-trace this, you see it memory mapped 8192, that's hex 2000, that's 2 pages, read, write, and executable. And it removed the write permissions from 1 page at that location, right? So the second page is still writable. So you can still have shellcode that writes to that second page. Now, say, how do I make shellcode write to that second page in a non-insane way? Think back to Embryo ASM. Which one was the level where you had to jump over a bunch of knobs? You can use the same thing here is what I'm saying. So if you wanted to, you could have in your shellcode, let's just say level 6, you have, your fix-up code that has no syscalls, and then you have repeating 4,000 times a bunch of knobs. Shit, I forgot this syntax off the top of my head. Let's take a look. And M. Okay, let's see if this works. What? This makes no sense. No. Okay, here we go. And R. Okay, that makes a lot more sense. All right, let's see if this works. So this should put in 4 kilobytes of knobs. Syscall 3 is already defined. What? Oh, oops. All right. 4 kilobytes of knobs. And the shellcode that is in the writable page of memory. Cool. And then we do the same thing. If we then SCP it, let's just do start.bin here. And then we cat level 6.bin. You can see that it is dying. Okay, let's do this without dash trace. See what it's telling us. Reading hex 2000 from standard in, removing write permissions, scanning through the shellcode. Okay, let's see what's going on. 1 second. Let's strace this. Maybe, okay, first of all, how big is this file? Okay, just over a page. Let's make sure that it all got read in. Strace will lock to standard error. So we're going to redirect that to standard out. I have a feeling that the read didn't read everything. Oh, come on. Okay, this is a giant pain in the ass. Okay. There. Reading. Oh, there it is. Nope. Yes. Read only read in 1 page. I wonder if this is here we go. Okay, read only read in 1 page. Can we do this way? Boom. All right. So this is interesting and would actually make a fascinating level for embryo IO looks like if you cat and pipe into a process. First of all, read is guaranteed to read no more than the amount that you pass to it, but it could read less than that amount. And whether it's because the buffer size of the pipe in the kernel or how cat works, could be either. We could actually figure it out by stracing cat. We ended up reading in only 4096. In fact, if you want to read in an exact amount, you need to run read in a loop to read in more and more until you've read the correct amount. Let's see how strace cat level 6.bin works. It'll write. Yeah. Okay, it wrote the whole thing. If we did this, but what if we do? There's a way to strace out into a file, right? Oh, yeah. So let's see what happens if we, okay, so if you just cat out a file, that writes the amount that we expected to write. Write also doesn't guarantee that it'll actually write out the entire buffer to the file descriptor. It'll return how much it successfully wrote. So let's run the challenge and see how much. So cat writes the whole thing, but cat writes the whole thing, but the challenge when reading from a pipe, oh, here it read the whole thing. Was it strace that made it? No, this is also strace. I have no idea why it was only reading a page before. But here you can see that we open our flag. Now, why did we get a permission denied? Well, that's because when you run things in strace, it uses ptrace to start up that process. And the process, so it starts up the process attached to it as a debugger, the challenge process, and then Linux will not honor the setuid bit, because if you're debugging a process, you can force it to do anything, and if you're allowed to debug a setuid process, then you're basically given root. So when you're stracing or running something in GDB, it'll ignore the setuid bit. All right, let me catch up on the chat. Dude, Knops is the correct way to pronounce Knops. Knob. All right, let's see. Knob. Okay, cool. So to summarize what we learned, the first time I executed this shellcode, and let me scroll all the way back up. I did this cat of the shellcode, and I ran the strace, and I grepped for read. Again, okay. We've reproduced it. It only read 4096 bytes. and so it won't have opened the file. Oops. Ah, fuck. Yeah, it only opened its libraries while loading. Now, if we do this, if we redirect it just using straight up the correct way, file redirection, instead of abusing cat, this works. Opens the flag. I mean, of course, it tries to, but since we launched it in strace, it doesn't have the permissions. Now, if we strace cat, oops, hold on. God damn it. This works again. Huh. If we strace cat, that's when it worked. If we run this without stracing cat, it doesn't. I'm confused. But this didn't work before, right? Maybe it's non-deterministically based on some other insanity. Anyways, it's not important. The point is, if you're careful about how you redirect things, it'll definitely work. And you can do the exact same thing and bypass that inability to read, inability to override the first 4,000 bytes of your shellcode, the first 1 page of your shellcode, by including 4,000 ops. Now, the awesome thing is, because this uses RIP relative addressing and is figured out by the assembler, I didn't have to change anything else. I just put this in. Awesome stuff. All right. The pipe comes from strace, not cat. Technically, but strace just passes it to cat as standard input anyways. This is very fascinating. All right. Anyways. Yeah, so someone on Twitch pointed out, I never changed this stuff. All I did was add in a shit ton of knobs, and then this all worked perfectly because the assembler figured out the rest. The assembler is a good friend when you're writing shellcode. All right. Can we do level 13 before class ends? And I don't know if I want to be giving away answers to levels that late, but let's take a look at level 13, and then I will bestow some wisdom. All right, here we are in level 13. Let's look at level 13. Level 13 is 12 byte shellcode. So, first of all, someone on Twitch said you can't make multi-stage shellcode. What does that mean? If you look at this strace, it first reads it, maps it read, write, execute. If I give it shellcode as A, it will remove the write permissions from that page, and one page is all that it mapped in the first place. So there's nowhere seemingly we can write, or at least nowhere that's readable, writable, and executable. So we can't fix up our shellcode, and probably or rather, we couldn't read in more shellcode over our own shellcode to execute because there's nowhere to write it. And so we just need to get the flag out. All right. So, there's a couple of ways that you can solve this. One way is by now, you should have gotten to a point where you can leak the flag with one syscall. Right? There are many ways to do that. One way we already mentioned with chmod. Another way is execve. Right? With execve, you can execute a command. You can execute a command with the same effective user ID. What might that command be? That command could be a command that you created. Let's say X. That can even be a shell script that just casts a flag. Why does this shell script run with bin sh-p? Because that causes bin sh to keep its set UID bit. So if you can execve X, you're golden, right? That's one way to do it. Another way is to chmod/flag. But of course, as I talked about last stream, with symlinks, you don't necessarily even need to say /flag. You can say y, and y will be /flag. And I alluded to that in one of the memes from the meme review, or who the meme author alluded to it. That you'll start out with something like A, or I just did Y, and then you'll end up with a capital Z, because for whatever reason, the value of a capital Z is useful. 5A. Or you will end up with garbage, right? This is the true kind of ascension of shellcoding, let's say. But the point is, you should plan on doing one syscall to fit into 13 bytes. Now, that becomes easy, right? Clearing out a register, that's 2 bytes. XOR EAX, EAX. Right? Is it 2 bytes? Let's take a look. Okay. Yeah, 2 bytes to clear out a register, right? So of course a syscall might take 2 or 3 registers, so that's 4 bytes, let's say. You need to set a syscall number. I don't know, we're just gonna set it to 42 just for fun. 4 bytes, 8 bytes left. Eventually you'll need to do syscall, 6 bytes. 9 bytes? Oh, sorry, not EAX. AL, 6 bytes, right? Move EAX 64 or 42 ends up putting a bunch of null bytes because you're moving a 32-bit value, this value, into EAX, which is this B8 instruction. If you use AX or AL, that's an 8-byte, 8-bit. That just has P0, which is the encoding of that, of move AL, and then this star. All right, which is ASCII for 42. So that's 6. You're halfway done with your shellcode, and all you need here is something to make the syscall make sense. That depends on the syscall you're using. That's one hint that I'll give you. Another hint that I'll give you is why do you clear out stuff? Why this XOR EAX, EAX? The XOR EAX, EAX is there because EAX could be anything, right? because our shellcode just runs in the middle of whatever. But that's not quite true. Your shellcode runs in the middle of a program that you're exploiting. Most of the time, that environment is under your control to an extent. Not like the environment variables, but what I mean is the program state is under your control, or at least predictable to some extent. So let's take a look in GDB and see what is the state like when our shellcode runs. I'm going to manually create a this is a interrupt instruction. So this is our there's a way to do this, but I forgot. Anyways, this is we don't want that new line. This is shellcode that will just do an interrupt, and then a trap, which will drop us into a debugger. So let's run the challenge with this interrupt. Boom. So our shellcode starts running. It runs int 3. Int 3, as I mentioned before somewhere, is what GDB uses when you set breakpoints. It actually replaces the instruction at that breakpoint with an int 3, so that when the processor executes an int 3, it makes a system call, and the kernel figures out who's the debugger for the process and triggers the debugger. All right. Here you can just do info-reg and see what's happening here at the start. One thing that's happening is RAX is 0. So this XOR EAX was a complete waste of 2 bytes. And we had no way of knowing that without taking a look at what's going on here. Now, there are other interesting things. One interesting thing is our 10. Let's see, this is pointing to a new line. R13. Come on, someone has to point. This, by the way, is something that the various GDB distributions such as Jeff and pwn.debug and pwn.gdb make a lot better. It'll automatically tell you what's pointing to strings and so forth. Let's take a look at this guy. Nope. Oh, that's definitely not going to fly. Ah! Now, this might look familiar for those who have been following Twitch very carefully. What the hell is h equals? I don't know, but it's there. It's there, and it is a null terminated string ready to be used. Cool. All right. Was that an RCX? Yeah, that was an RCX. Now, why is RCX pointing to h equals? Who the fuck knows? Actually, I have an idea of why. RCX gets set by the kernel when it returns to a syscall. I bet that if we look at 2 bytes before this, it was a syscall instruction. When you trigger a syscall instruction, RCX gets set to the next instruction, and it actually never gets unoverwritten. But anyways, this is actually an instruction, and it was, let's see what it was. It was a compare to see if why. God damn it. Every time I make a new pwn.college account, I have like a lot of suffering with this. Okay, we compared RAX against a negative hex FFF, basically. And it's probably checking for some error code on the return of RAX. Cool. So the point is that this is a value you can use. And RAX, because it's 0, is a value you don't have to reset. You can just move AL whatever and set your syscall number. All of that, together with only doing one syscall, should allow you to fairly easily get down to 6 bytes. 12 bytes. 6 bytes, take a look at what is different other than the number of bytes between 14 and 13. Honestly, I think 14 is a little easier. All right. I think that puts us a little bit over. I'm having some trouble speaking through my decrepit and what's the term? Mortally decaying throat. Anyways, I'm gonna end it here. To summarize, we went over level 5, 6, 13, and some other concepts. All right. I want everyone in the class to have, by Thursday, at least those whatever 6 levels now that we've gone over almost all the way through. Let's do it. In the meantime, please, please, please go and watch the modules for sandboxing. Boom. These 4, Connor's going to get them up on Dojo so that you can just click and watch. Don't watch the lectures. Definitely watch the lectures. All right. Awesome. Thank you for jumping in, and good luck. Zardis out.